Hi students, welcome to the mechanics of materials class. In the last video, we completed Lamis theorem concept oriented problems. Now we'll move to the one more problem. Just see the figure. So two symmetrical balls is going to be support one ball which is weight is 2000 newtons, and these two symmetrical balls are weight is 1000 newtons, and these two balls is connected by a string AB, and the distance is 40 centimeters, and the radius of balls are 15 centimeter, already given in the question. So finally we have to find how much tension in this AB string, as well as what are the reactions at D and E. So we have to calculate. This is the one. So before going to start the answer, first of all try to draw the free body diagrams of three figures. So then only you can decide which one is easy to take up for calculation part. Okay, so the radius is 15 centimeter for all balls. Okay, first of all I'm going to take this 2000 ball. See, so this is a circular ball or smooth cylinder, whatever it is. So for this case, here one more joint case is there. If you observe the joint, here also one reaction will come. Okay, so I'm going to represent in the free body diagram. See, the reaction force is coming like this, and next one more reaction force is also coming like this. So this is the contact forces or reaction forces acting on this particular cylinder. Means I'm going to draw I'm going to isolate this 2000 Newton cylindrical ball. What are the contact forces acting on this symmetrical ball? I'm going to represent. That is the free body diagram. And one more force is acting on this ball is weight. So weight is always acting vertically downwards. So this is the third figure, third symmetrical ball. Now you just so here I am considering A, B, C, D, E completed. I'm considering this point is G point and this point is H point. Sorry, this point is this point I'm going to consider F, and this point is I'm going to consider H point. Okay, this is the third figure. Now I'm going to take first ball, first cylindrical ball. See, so I'm going to isolate. Isolate means we have to separate the all contact surfaces, and what are the forces acting, externally acting on the body. I'm going to represent in this diagram. See, so weight is always vertically downwards. So this is W, and next one here one reaction force is acting. So this reaction force is always acting vertically upward. So this nomenclature is I am taking RD, and there is a contact force for first ball and third ball. So when you observe these two balls, there is a contact force. So that I am representing F point, so that there is a contact force, that is pushing force. You just assumed as pushing force or contact for whatever it is. So that is I am considering RF. Okay. So lastly, so one more force is acting on this first ball. So that is a string force which is connected for first and second ball. You just observe this string force is acting like this. So I am going to represent this is yes. Okay. So and the entire diagram is in symmetrical structure, so that if you consider the second ball, and it is similar to this one also, I mean similar to the first figure, but again I'm going to draw the first second ball also. See, so this is the second figure I'm drawing same reaction, that is a reaction force at the bottom is coming, I mean going upward direction, that is RE. And next one, the string force is acting towards left side direction. Here the string force is acting towards right side, but here it is left side direction. And there is a one contact force for between second ball and third ball. You just observe here. Here the nomenclature I am taken as H, so that the contact pressure is acting here, that is H, and the weight is always vertically downwards. So when you observe the first and second identical balls, see these two cases are very symmetrical. Okay, and this image and this pre-image is equal. Okay, so after you just first of all you have to draw all free body diagram for all balls. Then after you just decide so which one I have to take for calculation, and you have to decide which one is easy to solve. Then only the problem is going to be completed. So if you consider either one or second ball, it is very complicated to solve. If you want to take first and second ball, very complicated to solve. But when coming to the third figure, only just to see this, only three forces are acting. So this is weight is always acting downwards, and the reaction force, that is RF, and the reaction force is RH. Only three contact forces are acting. So we have to find these two reactions, that is RF and RH. Why? So this W already known. So what is the W? 2000 newtons. Okay, and directly you will go, I mean you can apply the Lamis theorem. So after calculating this reaction at F and reaction at H, then you can come to the either first ball or second ball. So then only you will not feel difficult. So I am going to take the third ball for calculation. See, yeah. Yes, I'm going to consider the third figure. So this is RF and this is RH. So these two are acting at the contact, and weight is acting vertically downwards. Still now we don't know the angles for this RF and RH. So first of all, after finishing, after decision making of this identical balls, and go for the calculating the angulars if there is any angle cases are there. So for this, again you just choose the choose this diagram. See, yeah. So here A to the G point, I mean F point. If you I'm considering this is the F point. A to the F point is the radius of this circle or radius of the cylinder, and F to the C point is also radius of the circle. So radius already given in the question, that is R is equals to 15 centimeters. So all the three cylindrical balls radius is equal, and draw the perpendicular line from the center of the circle to the this string point. You just draw the center of circle of third one to the string point, so automatically you will get one angle. So what is that? I'll draw. See, so this is the diagram. So after getting, so this is the F point, I mean this is intermediate point, and and there is a perpendicular line, so which is contact to the AB line. Okay, now I am considering this is the theta. Okay, and this is 15 centimeters, and this is also 15 centimeters. So here from A to B is 40 centimeters. So this point is going to be contact exactly at the center, so that you have to consider 20. So here if you consider this is theta, and this is adjacent side, and this is hypotenuse. So adjacent hypotenuse combination is cos theta. So cos theta is equals to 20 divided by 30. So finally we'll get the theta value. So theta value is equals to, yeah, see this one, 48 point, so 48.18 degrees. So theta is equals to 48.18 degrees. So then after I'm going to calculate the remaining cases. See this, so I already mentioned. So this is the circular ball. So here the RF reaction force is acting, and next one here RH force is acting at this point, and the weight is always acting vertically downwards. Now I am projecting this RF to the top direction. So RF I am projecting the top, and RH is also projecting to the top. So final diagram is like this. See, so this is the intermediate point. So all the forces are meeting, and this is W, and this is RF, and this is RH. Okay, so you already find out this theta value. You just take as so this is the theta. So theta is 48.18, and this is also same angle. Why? Because symmetrical structure, so that angle is 48.18 degrees. So finally 90 plus 48.18 degrees will be equals to the 138.18, and next one, this is also 138.18 degrees. Okay, what about this one? 360 minus 138.18 and 138.18. Finally we got some one more value, so that is 83.34. This value is 83.34. So now you can apply the Lami's theorem. Why? Because we already known this W value, that is 2000 newtons. So only three forces are acting, and in which three forces, two forces are unknown and one force is known force. So directly you can apply the Lami's theorem. I already explained in the last videos how to apply the Lami's theorem. See, so when you take this just RF and RH, So RH divided by sine 138.18 degrees and RF divided by sine 138.18, and finally W divided by sine 83.34. So finally I got this RH is equals to 1341.84 and RF is also same value. So both the values are same value. Why? Because the complete figure is in RF is equals to RH is equals to 1341 something newtons. So given question is in Newton, so that final answer is also in Newton. Let's find so finally we'll finish this one parameter. Now we'll move to the either you select first ball or second ball, your choice, either first ball or second ball. I am taking this first ball, and this result will reflect to the second ball also. So why? Because the structure is in symmetrical case. See this one. So this is the first ball. The reaction force is acting upward direction, that is RD, and the string force is acting in this direction. Yes, I am considering, and this is RF I am considering, and this is RF, and finally weight is acting vertically downwards. So these are all forces are acting on the particular body, and final diagram I am going to draw like this for meeting at point. This RF is projecting like this. See this? So this is RF, and W is acting like this, and S is towards right side direction, and RD is acting upward direction. We know this angle. This is 48.18. 48.18. But what about this angle? 90 minus 48.18. 90 minus 48.18. So this is the case. Now this finally we got this one as yes, 41.82. This value is 41.82 degrees. So now you can resolve this RF into two components. Here the theta makes with which axis? Y axis. So that you can resolve this RF into two components. One is RF cos 41.82, and for vertical component, and this is case RF sine 41.82. So why I am taking here cos and sine? I already discussed in the previous videos. If you just observe theta makes which axis? Okay, if theta makes x axis, then you can take the cos theta for x. If theta makes y axis, you can choose the cos theta for y axis. Other than this theta, you can choose the sin theta. Here theta makes y axis, so that I am considering RF is equals to RF into cos 41.8 degrees. So next, how to calculate this case here remaining RD and string force? How can we are going to calculate? We already we already known this RF value, so that is 1341 point something newtons. So in this case, you just see how I am going to take. You just select method of resolution concept here. So see, summation of H is equal to 0. So what does it meaning? What are the horizontal forces are acting? Here RF sine 40, this is 41. RF sine 41.82 is acting towards left, and string force is acting towards right. So just take as RF sine 41.82 and is equals to, directly I am taking is equals to S. So finally I got S is equals to 894.74. As the same thing, when you consider the summation of V is equal to 0. Summation of V is equal to 0. See this. So W is acting downwards and RF cos 41.82 is also acting downwards. But RD is only RD is acting upward direction. So that you can consider RD as positive. So remaining 2 as negative. So that's why I am writing right hand side. So see this RF. So like this I am going to write. See RD is equals to RF cos 41.82 plus 1000 and finally I got 2000. So what about RE case? What about RE? I already told you this is a symmetrical structure. So this value is similar to all cases. So RD, what about RD value is I got 2000 newtons. At the same thing RE is also 2000. So without calculating, we can go. We are going to calculate RE and RD. How I am going to explain. So in coming problems, this point is going to be this point is going to become. So what are the forces are acting downwards? So 1000, 2000 and one more 1000 is acting. Total forces are 4000 newtons. So you just this is a symmetrical structure, so that final answer will be means that is RD is equals to RE is equals to total loads divided by 2. Loads divided by 2. So total loads is 4000. So that is 2000 is acting and remaining thousands 2 are there. Overall calculation is 4000 divided by 2. So finally we got 2000. So without calculating you just remember like this. So this type of things only symmetrical case. You just remember. So this type of calculation will appear only in symmetrical case. In coming problems, calculate reaction of beams or reaction of support beams. So this parameter will come. So we'll see in the in coming video also. So thank you. So in the next video we'll see one different problems regarding this Lamis theorem or reaction of support.